Right, can you see it's recording? Great. Well, hello. This is the fifth in our Talking Heads for the our Talking Heads series for the Soil Health and Carbon Dynamics topic advisory group of the Land Use for Net Zero People and Nature Hub. So over to you, Pete, to introduce our experts.
Yeah, thank you very much. So today we're talking about biochar. We've gone to Professor Colin Snape and Dr. Tom Bott, who are both at the University of Nottingham. Colin leads the greenhouse gas removal demonstrator on biochar. So we're in good hands today. So we've got a bunch of questions which we're going to ask you and try and get to the bottom of what's going on with biochar and how it interacts with soils. So thanks for being with us today.
So my first question is very simply, what is biochar and where does it come from?
Yeah. First of all, thank you very much for inviting us along to this particular session. But biochar you can look upon as a form of charcoal. We'll get into it. There are some differences, but it is essentially a carbon-rich material that's produced by heating, carbonizing biomass in the absence of oxygen. So it's made the same way that coke that we've used in blast furnaces for over 100 years. And I think an important issue is the scale at which you're going to produce biochar, which is very much dependent on where your feedstock is located. But I think if we're talking about biochar making significant contribution to greenhouse gas removal, then we are looking at production facilities of the order of 1 to 5,000 tons of biochar a year. So we are essentially looking at a small chemical plant rather than a series of isolated small kilns. Small kilns are fine, but you might imagine with the issues around wood burning stoves, if you have 20,000 kilns dotted across the country, then there could be a pollution problem, which you do avoid with larger facilities because they have to be fully permitted by the Environment Agency in terms of emissions.
So thanks, Colin. That's how we produce biochar. But biochar is applied to soils, right? So how does that happen? Tom, maybe you could answer that question.
Yeah. I think if I could just add very quickly to Colin's answer as well for the first one. So I think something we quite often forget is that biochar is a bit of a catch-all term. We can have lots of different feedstocks and a variety of different pyrolysis conditions. So that means that not every biochar is going to have the same properties. So if we're talking about biochar that we want to be very stable in soil and to perhaps act as some means of storing carbon, you will probably be wanting to use a very carbon-rich feedstock, let's say wood, and then pyrolysing that at a higher temperature, and it'll be much more stable. If we then look at other biochars that maybe with more nutrient-rich feedstock, so we could look at something like chicken litter and maybe pyrolyze that at a lower temperature, we might then see something that's less stable in soil that might have more of a fertilizer-based effect. So it's just something that maybe we should identify at the beginning as we go through this, that there are different biochars that are potentially different effects to soils. Yes, so in terms of applying it to land, so a lot of the research that we're doing is working on commercial-based farms, and that's something that we've been really trying to work out. So how do you get 10 tons of what is a very light material spread onto land using already existing agricultural machinery? So if we're talking arable farms, we've been trying things like lime spreaders or muck spreaders to try and get that cast and spread. That's something that we're still working through with contractors, trying to work out how that's best done. Because the material is so light, it doesn't perhaps spread as far out the back of the machine. So that requires a little bit more passage or movement across the field. Then once it's spread onto land, you can then either leave it on the surface or you can plough it in and incorporate it into the top of the soil. In other environments, let's say we're talking about forestry instead, then we've done things like burying it. So it might be as simple as digging the hole for the tree, putting a couple of handfuls of biochar at the bottom, handful of soil, tree on top, filling back in, or digging a trench, putting it in the bottom of the trench, putting the trees on top of that, or even we've tried as well leaving it on the surface around the base of the trees to gradually work in. And then sort of carrying on from that as well, on pasture-based land, we've done the same thing where we've spread it to the surface and then we've allowed the grass to grow through. And there's one site which we couldn't actually find the biochar. After only 3 or 4 months, the grass has done such a good job of growing through and incorporating it into the topsoil. Me and the other researcher on the project, we were having an argument about whether we were in the right field. It was that well hidden. So yeah, there's a whole range of different ways to do it, and it does sort of depend on the scenario.
Thank you, Tom.
Thanks. Well, so that's that's how it's applied, and how effective it can be. Could you talk a little bit about whether there are other sort of more external environmental factors to take into consideration, and just a little bit around the limiting factors and the extent that might be involved in biochar deployment?
Yeah, because I think I've already touched upon biochar production, and providing that is done at scale, essentially in what is a small chemical plant, then you are applying very high emission standards. What might happen when biochar is spread to the land? Biochar needs to have pretty reasonable strength, because in farm machinery, lime spreaders, muck spreaders, it can very easily get broken up. I think for storage, because if you have a great big pile of biochar, there is a risk that you may end up with spontaneous combustion. So our advice is always keep it wet. So you're clearly spreading. Again, keep it wet, and that way you should avoid ending up with a dust cloud. Once biochar gets into the ground, and clearly the issue is what might leach out, and I think we can come back later to touch upon voluntary biochar standards, which are well established for different applications later on.
Yeah, I think to add to that, once the biochar's in the soil, that's it. There's no real way of getting it out. So what we put in, we need to make sure is safe and is going to be stable, and we understand the sort of impact that it's going to have in that situation. So yeah, it's once it's there, it's there.
Yeah, with that in mind, are there any differences between applying it to different soil types, like very clayey soils or very sandy soils? Does that affect how much the biochar is retained, or any environmental side effects?
Yeah. So I think we'll probably talk about this again more in future questions. But yes, so if you're talking about applying biochar to a very acidic soil, it's got very low fertility, that's very sandy, let's say, adding biochar to that might have much greater impacts in terms of improving the soil water holding, maybe the nutrients within it, improving its acidity, or making it more neutral. That will then support crops and growth, compared to maybe putting it onto a more neutral soil that's a loam that you perhaps more commonly see in the UK in temperate climates. So there is sort of a bit of a thing about picking the right biochar perhaps for the right soil, or at least being aware the biochar that you pick isn't going to have a negative impact. So that might be, if you already have quite an acidic soil, biochar might not be the best thing to add, or if you are going to add it, look for a biochar that's already quite neutral, not one that's more basic.
Yeah, I mean, building on that, I'd be interested to hear about sort of wider safety questions around biochar, if there are any potential negative or even positive effects on the wider environment.
Yeah, I guess this gets us into the question: what is a safe level of biochar addition in soil? If you're coming at it purely from a greenhouse gas removal, it's a case the more you can add to soil, the better. I think it's worth starting at the current legislation is governed by the Environment Agency's low risk waste position, which by definition has to be precautionary in nature. And that basically says, yeah, you can apply 1 tonne of biochar per hectare from a given list of feedstocks, essentially wood and agricultural residues. You can't store biochar in any great quantity. And I think if you do your sums, because we haven't got a huge amount of land of the order of 6 million hectares, and once you do your sums and applying a tonne of biochar per year, maybe up to a sensible limit of 10 tonnes per biochar, then that is not necessarily gone a very long way to make a big dent in the 2050 greenhouse gas removal. So the one thing we've did, and we've got environmental approval, agency approval for each of our trials, is essentially go to 10 tonnes per hectare from 1 tonne per hectare. Even though 10 tonnes per hectare does sound a lot, if it is tilled into a depth of, let's say, 20 centimetres, that's still only halfway percent of the soil mass. And Tom can go into this in greater detail than I can, but from all the mesocosm experiments which are done, generally, yeah, Tom, you'd say once you get beyond about 5% addition, you're then starting to see negative effects, because biochar is just locking up everything far too strongly. So, Tom, I don't know if you want to add a bit more regarding potentially safe levels of biochar addition.
Yeah. So I think we can approach this in 2 ways. I think we can see this as a long-term repeated application, reaching a point then where there's too much biochar in the soil and we're having problems, and also just putting on too much in one go. So if we think about like long-term and applying lots, you're eventually going to reach a point where the biochar is binding everything. So if you're applying nutrients or you're trying to apply pesticides, you have the real problem. The biochar is going to be binding that and stopping it from acting. But you're also going to start running into problems with actual soil texture and structure. So once you start reaching a 25-30% volume biochar, you're not going to have that soil structure, and then you're going to start seeing problems with erosion, too fast drainage, problems with root growth, or like roots being able to actually collect water. So then effectively you compromise that soil, and you can't keep going. We think about it just as a very high application at the very beginning. We're going to have real potential problems with that biochar, which has got a very high surface area, can bind a lot of material to the surface of it. It's going to take a lot of nutrients out of the soil. And if you're also then trying to farm that and you're applying pesticides or herbicides or more fertilizer, the biochar is just going to be soaking that up and it's going to be working against you and stopping you from having a productive year, or 2 or 3 years until that biochar is fully coated and charged. But I think there's 2 sides to that. I think one way to look at it perhaps is a little bit differently, is instead of applying it raw, is maybe co-applying it. So doing small amounts of biochar application mixed in with something like compost. So the biochar is then already charged with nutrients from that composting process, and then applying that to land. That can then perhaps mitigate some of those effects of biochar soaking up nutrients, which might be a problem even with lower amounts of biochar being added. But again, it's going to end up being a soil specific thing and a biochar specific thing.
Can I just ask you, for those who are completely uninitiated, when you talk about charged biochar, what is that process? What does that actually mean?
Yeah, okay. So as I mentioned, biochar's got a very high surface area. It's got a high porosity, or some of them do. And so that means it's got a lot of raw surface on the top that have got basically chemical binding sites, or sites with a chemical charge. So what that means is that nutrients or metals from the soil or other things from the soil are going to get stuck to it. So you effectively got this naked piece of carbon in the soil, and then any nutrients that are in the pore water, instead of going to the plant, are going to end up stuck on the biochar, and that will then have that negative effect that you don't want, because it's not going to the plant, or it's not going on to the pest or the herb you're trying to remove.
Thanks.
But Tom, yeah, whilst could be a negative effect, can also be a positive effect, because particularly for nitrogen fertilizers, which we can come and discuss in detail, that is really the strategy is essentially applying it with biochar to clearly reduce runoff and potentially reduce fertilizer use, which then clearly has core benefits in terms of knock-on reductions in greenhouse gas emissions.
Yeah, that's really, really useful. Thanks very much. You've already mentioned that biochar is not one thing, right? There's lots of different types of biochar. It depends on the pyrolysis temperature and the feedstock. And presumably the feedstock, if you're using waste wood from construction, you could have paint on there, which could cause contamination and things like that. So there are some don't do's for making biochar. But are there any sort of good practice guidance or specifications or standards for biochar? And do you have to, for every batch of biochar, do you have to go and measure it to make sure that there aren't pollutants? Or, are there any sort of legislation around the standards?
Yeah. Yeah, Pete, in terms of voluntary standards out there, essentially doing two things. One is checking the obvious pollutant levels, heavy metals, pHs, etc. And the other thing you are wanted to get a handle on is long-term stability. And if we start off with the latter, carbon trading platforms such as Pure Earth are essentially all coming up with their own methodologies, but really, to cut a long story short, if your biochar is prepared at high temperature, it will meet the required stability criteria, which means you will get maximum payment for the carbon which is being sequestered. High temperature biochar may be not the best, because as you've got high pyrolysis temperatures, you are losing surface functionality in terms of what might bind to the biochar. But the European biochar certificate, which is now morphed into the World Biochar Certificate, does present quite stringent limits on heavy metals, pHs, and typically the levels in the biochar are probably no higher than what you've got in the soil. And there are essentially three grades of biochar. The top grade is what can go into animal feed, and this is attracting much attention, particularly for cows. And as we know, there are a variety of approaches to reduce methane emissions, such as seaweed dyes, but biochar does have an effect. So as you imagine, that is really top of the tree. Next grade down is agricultural grade, which is still very stringent. Then below that, you've got biochar going into aggregates, and given whether that is for construction or whether it is for roads, steel slag, coal fly ash go into aggregate materials. So you can imagine the specification is somewhat lower. And even though we're not going to talk about aggregates today, if there are limits on using biochar on grassland, arable land, forestry in the UK, aggregates does potentially represent a huge resource for sequestering carbon.
Right. Okay. So despite being a fairly young industry, then there's quite a lot of legislation and safety protection around the biochar. So it's not just a wild west out there. There's a lot of legislation in place already in order to protect the environment.
Yeah. So I think in terms of setting the standards, the wild west element probably comes into monitoring, reporting, and verification, because the way the carbon platforms operate, they're not going to send somebody along to every farm to check that the quantity of biochar that's being reported is actually being sprayed. And this is really where government needs to step in and set above what one has to do for voluntary carbon trading markets, what additional measures do you want in place so that the biochar is being deployed in a perfectly acceptable manner.
Perfect, thank you.
I wonder if you could say a little bit about how the long-term stability of biochar is assessed.
Yeah, so clearly this is an issue. Will biochar in relatively shallow soils, will it microbially degrade and over what time scale? And some of the evidence for the long-term stability comes from ancient charcoals and terra preta soils in South American, cultivated by the Amazon 7,000 years ago. Clearly you can go on and collect intact pieces of charcoal. And again, for ancient civilizations, all the dating really depends on charcoal that's been recovered. So that is the evidence that charcoal will survive for periods of thousands of years. However, there is evidence that there is a fraction of biochar which will degrade over much shorter timescales, periods of tens of years. And going back to what I said previously, the higher the temperature you prepare charcoal, the more stable it's likely to be. Not to give you a chemistry lesson, but you are essentially building larger and larger clusters of polycyclic aromatic hydrocarbons. We've developed our own method, which is gaining a lot of traction globally for using a measure of stable polyaromatic or persistent aromatic carbon to give a handle on long-term stability. So typically biochars prepared at high temperature, will have a stability index of somewhere around about 90% on our measure. So I think, the evidence is there that biochar can certainly survive for periods of 10,000s of years, but yet there is a fraction that will degrade fairly rapidly, and that rate of degradation is going to be very much dependent on circumstances. Tom, anything to add?
No, I think you covered everything there. Yeah, and we can talk more about that labile or accessible fraction that degrades and that sort of positive impact that might have on soils when we get to it in terms of biodiversity and things like that.
The next question that I had lined up, which was one that we got the soils tag, I'm not going to ask because I think we've already covered it in the previous responses. So what we do is we'll edit this bit out when it comes to the final bit, and we'll just go straight over to Ellie's next question. Is that okay, Ellie?
Yeah, it's perfect. I think that kind of to your point actually, Tom. So yeah, following on from that, can you say a little bit about how biochar affects soil biodiversity in terms of species richness and functional traits?
Yeah, so there's quite a lot of evidence now coming out that biochar can have a real positive effect on soil microbial and fungal communities, improving species richness and abundance. Trying to pin down sort of enzyme activity and actual sort of functioning within the soil is a little bit more difficult. Again, it comes down to the soil that you're starting with and the biochar that you're applying. But in general, the research is pointing towards biochar having a real positive impact on soil health and function. And it can do that through sort of both an indirect and a direct method. So adding biochar, the biochar itself can act as a surface for bacteria and fungus to grow on. So you can have communities growing on there using nutrients from the biochar or for nutrients from the soil to be drawn onto the surface of the biochar to act with it. So then the biochar, once it's in there as well, can have more of an indirect effect, and that's sort of improving soil organic matter, improving soil aggregation through that. And then as well as that, it can also do things like alter the soil texture, so it can improve things like porosity, soil moisture, and all these little changes, and pH being another big one, all these little changes then adding up to making the environment more suitable for microbial communities to flourish and thrive in those environments. And then as well as another thing that we could possibly talk about is maybe the idea that it might be warming the soil a little bit as well. So you've got slightly warmer soils, and that can also then promote greater microbial respiration. We can caveat that a little bit by saying that sometimes you add biochar to soils and you actually see sort of like a positive priming effect. You actually see a flush of CO2. Because by adding that biochar in, you're providing more nutrients, you're disturbing the soil, and you then see an increase in CO2 emission. But that's probably transient, sort of it disappears after 3 to 6 months, and then we go back to more sort of aggregate formation and improved soil carbon.
Just
Yeah, sorry, I think the only point I'd like to add, Tom's made a very important point, because most trials involving biochar monitoring only last how long the grant is. So it might only be a couple of years, and as Tom said, you might be seeing some initial transient effect, which will settle down. With our trials, we are monitoring the fields over much longer times, which will be able to, say, tease out where we have an initial transient effect rather than something that might be long lasting.
brilliant. Just building on that, is there any sort of data at that spatial level emerging that people could use strategically to understand sort of in this soil type, you might be able to get these effects, or is it a bit early for that level of kind of strategizing still?
I think it's probably a bit early for that sort of level of strategy. It goes back to the idea that trying to, if possible, trying to find a biochar that best suits the soil that you're looking at. So we've talked about those indirect effects, changing pH or improving porosity or soil water holding capacity. If you were to then take a very clayey soil and then you picked a biochar that was very, very fine, and you added that to the soil, you're going to clog all the pores, you're going to end up with waterlogged. That's going to have the exact opposite effect that you want. So sort of more looking at that very basic level of, does the biochar's physical and chemical characteristics match what I wanted to do before I apply it, might be a better place to start, rather than trying to tease apart, really complicated microbial interactions.
Yeah, I think just to add that our approach has been very cautious when it comes to arable land, but in all our trials going to 10 tonnes per hectare, Tom, I don't think we've seen a single negative effect to speak of, which is good news. So, this is real evidence that the current regulatory framework could potentially shift from applying 1 tonne to 10 tonnes per hectare in a single application.
I mean, I would also like to add that there's areas of this that are still a little bit poorly understood, to particularly invertebrates at the minute is somewhere that hasn't been studied as intensely as maybe microbial communities. And so there's not as clear a picture coming out yet about the impact of biochar on invertebrates. Some studies say it's positive, some studies say it's negative. A very mechanistic understanding of why that's happening isn't really understood. It's probably likely due to those indirect effects, so changes in pH, changes in moisture content. But yeah, that's something that still needs to be explored a bit further.
More research needed then, and that's what we scientists like to hear.
Invertebrates, yeah.
Excellent. So you mentioned that biochar can affect the soil physical properties. Is there any evidence one way or the other that biochar could, affect the erodibility of soils? That's a very macro scale thing. So is there any evidence?
Yeah, and I think most of the evidence now is starting to point to biochar can have a really positive impact on protecting soils from erosion and loss. So it goes back to that idea of supporting aggregate formation and improving infiltration and drainage of soils. So if you've got stronger aggregates and you've got better water going in rather than running off, then that can really sort of reduce the effects of erosion. So that's the big one that's coming out at the minute. Yeah. That does, I think, vary again on the soil type that you start with. So I think the effects are probably much more noticeable in sandy soils and the tropical soils than maybe the ones you see in the UK. But yeah, we've got that evidence starting to come through now.
Okay, great, thank you.
I could also add to that as well that it's quite a synergistic effect. So we mentioned earlier about it. You reach a point where you've added too much biochar, you're damaging the soil structure, so you're going to end up with more erosion. But in that middle sort of area, you can also end up promoting root growth by reducing compaction, allowing roots to get in further. And there's that sort of double benefit. You're able to support better cover crop and also with the biochar supporting aggregate development as well. So
yeah, So you're getting the stabilization from the root network as well.
Yeah, and then you've also got the plants protecting it from direct
Yeah.
raindrop effects.
Absolutely. Yeah.
Well, I mean, the next question we've answered in some ways, talking about safe levels, etc. But it's something I think people are really, really interested in. So let's maybe just drill down into it briefly. So the question is, what impact does biochar have on downstream water quality?
Well, I think it should probably have quite a positive impact on downstream water quality. If we pick up on the erosion side of things, if you're reducing the amount of soil runoff into streams and things, particularly off of fallow farmland, then that's going to have a positive impact on water quality. The other thing that we've talked about as well is the fact that biochar can bind things to its surface. So if you're applying biochar to soil and it's then capturing some of the nitrogen and phosphorus and other fertilizers that you're applying, or pesticides, and stopping those from then leaving the soil and entering the water system, then that's going to be another real potential benefit with water quality. So yeah, you've got those two things. There's also potentially the fact that you could maybe use biochar in the future as a sort of filtration-based technique. So this is things that have been talked about in wastewater and stormwater treatment. It'd be interesting to see as well in farms if you could use it in ditches or in buffer strips and things like that to try and capture some of the runoff that's coming off the field and using that as a sort of filter and then protecting water courses and drainage on farms.
Yeah, one of my favorite, sorry, Pete, one of my favorite lines is, don't call it biochar, call it a low grade activated carbon, because in an ideal world, no cost constraints, we would use activated carbon for stopping runoff in terms of having beds. So, this is a huge opportunity that biochar has. You can essentially put it through some duty for pollution control. Then after that, you can then hopefully safely dispose of it. But, clearly there are issues in terms of what pollutants have been absorbed. But the one application that I've indicated is that biochar does end up into aggregate material. That is certainly acceptable under current regulatory frameworks.
Yeah, thanks very much. Sorry, go on, Tom.
Yeah, so there's also this idea as well that you could pyrolyze agricultural waste that might be spread onto land neat, and therefore if you pyrolyze them first and then apply them, then that might prevent some runoff coming from those very rich sources. There's probably not as clear with that because you want those fertilizers coming from that manure or that chicken litter and things like that, but it's certainly something that's being explored and discussed at the minute.
Great. So the next question I'm going to ask is about the interaction with pesticides, which I think you've already dealt with, but we'll try asking it again just in case we decide to tease it out as a separate question. Okay, so I'll ask you about that. We'll cut this bit out and we'll just go straight from the question. So you mentioned that biochar can act as an agent that clings onto pollutants and nutrients and all sorts of other things and keeps them in the soil. Would this also be the case for pesticides and herbicides? What would the interaction be between biochar or biochars, different types of biochar, and pesticides and herbicides?
Yeah, it definitely can bind to pesticides and herbicides. And that's both potentially a concern and also a potential benefit because you protect the environment from excess runoff. It does, of course, going to depend a little bit on the biochar and the biochar's characteristics. And it's also going to depend a lot on the soil that you're working with as well. But if it binds those pesticides, then you're potentially going to have the problem that the farm's going to need to apply more to have the effect. And another concern might be if the biochar then comes off the char at a later date, 3 or 4 months down the line, and then starts interacting with your cash crop. And that's something that we're still trying to understand. Conversely, though, if we're then also saying that, biochar can improve soil functioning and soil health and that sort of microbial turnover, then it might actually also be speeding up the removal of pesticides from the soil because you've got that greater rate of action. So that's another potential confusing influencing factor in all this. And so again, it's going to depend a little bit on the soil and the biochar, but there is a direct interaction potentially.
Thank you.
Yeah, similarly, and leading on from the question before last, around parts of fields, for example, that are not the main crop focus or grazing focus. Can you say a little bit about what the addition of biochar can have on, for example, field margins or areas that are managed for nature rather than for food production?
I think it'll have exactly the same sort of benefits and caveats that we've discussed if you're applying it to the main part of the land. So that being things like nutrient absorption and improved drainage, or even acting as a means of filtering the runoff that's coming off the fields. So capturing it before it enters a watercourse. Those are all things that it might be able to do. I suppose questions then come around if you're adding fertilizer to manage weeds, sort of by suppressing them, by improving plant growth. Is that going to work as well if you've got lots of biochar out on the surface, or if it hasn't been incorporated? But yeah, it definitely has a role, and all the things that we've talked about in other parts of the farm or in other soil scenarios, you're still going to see those benefits in field margins as well.
So we had a similar chat about enhanced rock weathering with Professor David Beerling just a couple of weeks ago, and what I'd like to ask is, are there any synergies between biochar and enhanced rock weathering? If you applied them together, either in the same product, or you applied them as different times in the same field, are there any interactions? Could they be synergistic? Would it have any benefits on, benefits or disbenefits in terms of fertilizing crops and increasing yield? Do we have any data on that?
Yeah, Pete, before we get involved in answering your specific question, in terms of stacking, we are doing quite a lot of work around peat as well, around paludiculture, where biochar does have obvious benefits in terms of stabilizing peat, and also for woodland. If biochar goes in the ground at the sapling stage, then you get involved in the calculation in terms of how much above ground transient carbon am I storing compared to how much below permanent carbon is being stored. But yeah, it's an interesting one with enhanced rock weathering, and clearly this is a way to maximize the use of land for GGR. I think I'll let Tom chip in on specifics, but just to mention that if you have a ton of biochar, then roughly you're sequestering something like 0.7 tons of carbon. You need several tons of basalt rock dust to sequester 1 ton of carbon. So you have to apply a hell of a lot more to get the same level of carbon removal. Then I think for enhanced rock weathering, there is a height profile that, clearly the deeper it is, will it react more slowly with CO2 and push your timescale out even further. So Tom, do you want to add anything?
Yeah, I mean, in terms of data, I'm not aware of any published data yet on the two of them being co-applied or work together. I'm aware of people doing the work. There's definitely something that the research is taking place, but I don't know of anything that's come out that sort of really explores it in depth on a field scale or in the UK.
Right.
Yeah, I mean,
right. Yeah.
I mean, we're working with European groups. Ithaca Institute, who are the main driving force behind the European biochar certificate. They have trials going on, and we've looked at impact of rock dust on pyrolysis in terms of affecting biochar stability. I guess, Tom, but one thing is probably pH. Given the nature of basalt containing obviously high concentration of calcium.
Yeah, I think that'd be the only thing that I can think of off the top of my head is that chemistry conflict that's potentially going on there. But sorry, I don't fully understand the mechanisms or how that works, I'm afraid.
Yeah, but that's fine. It's a matter of watch this space. There's research going on. So maybe in 2 or 3 years' time, at the end of the LUNZ Hub project, maybe we'll have more data on that. So that's reassuring. Yeah, thanks.
I think it's definitely something that's interesting. It makes sense to try and stack But at the
But
moment,
I guess, Pete, because I think you know how the GGRD program has worked, that each demonstrator was funded separately. Then at the start before that, you know, we had no idea what else was being funded, but that's one of the real positives to come out of the GGRD program. That, you know, stacking combined use of approaches is very much seen as a way forward to maximise land use for GGR.
Yeah. We should go back to the funder and suggest that for phase 2 of the GGR demonstrators.
Yes.
Yeah. And the other thing, I mean, we're probably not the best people to answer this, but I mean, how are we going to reflect the carbon that's sequestered in the biochar in the national inventory? Do we currently have a way of doing that, or even with enhanced rock weathering? You know, can we reflect that in the national inventory of greenhouse gases so that we can make sure?
That's a great question, Pete, because clearly government needs to put in measures so they collect the data on top of what's happening in the voluntary market. Because if something happens in the voluntary market, then government doesn't necessarily get to know about it. At the minute, I can talk a great length in terms of the regulatory framework, you know, which does, as of today, limit the amount of biochar that can be deployed, you know, in terms of what feedstocks you use to make the biochar. And as already mentioned, you know, low risk waste position, you know, you can't apply more than 1 tonne per hectare per year unless you get permission dispensation from the environmental authorities to do that.
Right, so that's some work to be done there about making sure that we can reflect all this in the national inventories, and I suppose also to make sure that we don't double count those carbon sinks.
Yeah, precisely.
On the carbon market, you know, and within the UK's territory. So that's something to be worked on. I think maybe something we could take back to government.
Yeah, going back to those really practical questions. I was wondering if you could say anything around whether in your mind you'd like to see more clear structure given to people in terms of whether application rates need to be really tailored to that kind of matrix of soil type, land use, farm management system, topography, that kind of more holistic way of looking at how people who want to engage with using biochar can actually do it to the greatest effect.
Yeah, as definitely. I would say that that's something that needs to happen. But I guess the problem that I see within this is supply. You know, it's all very well telling people that you want to avoid a biochar with these characteristics to match your soil, and you don't want to apply too much of it. But if they can neither get that much of it, nor can they get a biochar that matches that, then there's going to be a real issue with that. And I think it's also going to be a thing of training as well as this becomes, or if this becomes more prevalent, and this is going to be something that maybe more agronomists start to understand, and it's a conversation and there's been an actual market for different types of char. I guess Colin can talk about it a bit more as well, but it's also going to depend on whether or not it's even feasible to move those volumes of char. You know, if we're talking applying 10 tons per hectare, and the plant that produces the char that's going to have the best sort of match with your soil is in Scotland and you're in Exeter, that's not going to work. So you're going to have to try and sort of balance what char you can get with what you want. Sorry.
Yeah, Tom, I think char composition is very much going to be controlled by stability, because that really is a key factor in getting maximum income through carbon trading. So in a way, you are taking out preparation temperature. Then, you know, clearly the other factor is potential influence of feedstocks, and you know, ideally, certainly we don't want to be chopping down trees to make biochar, because that does clearly introduce a big life cycle issue. The ideal feedstock is, if you did nothing with it, it would rapidly degrade to greenhouse gases. So you are essentially then getting maximum benefit. And you know, there are numerous examples, you know, particularly digestate from food AD at the minute. A lot of that has to go to incineration, because it cannot be spread to land, because it does contain relatively small amounts of plastic, and potentially making biochar does present a solution where you are getting that benefit with respect to greenhouse gas removal.
Yeah.
But I think in terms of getting benefit, then we are probably looking towards more, certainly in England, towards the east, sandy soils.
Yeah.
And I think then the issue, for farmers is, okay, I might get some slight benefit, but clearly, in terms of the value chain, farmers need to be recompensed for the service which they are provided, and these are some of the issues we've uncovered, because in terms of arable land, very little deployment will happen unless the farming community is completely on side.
Yeah. I think as well, sort of building on that, is the idea that understanding the positive effects that biochar can have in specific areas. So we're talking about Norfolk and the idea of having sandy soil. Going for a biochar that we know is going to have a great impact on water holding capacity, which can then reduce irrigation. And that's something that we can then really sort of sell to farmers, saying that farmers can pick up on. And it can then also become an idea of just a general rule of guidelines of when to apply it, how to apply it, maybe what to apply it with as well. So something that we're talking a lot about is this idea of co-application. So if you're taking the biochar in a raw form, then putting it into green waste and composting it, and then spreading the compost, you're still getting the biochar onto the land. You're applying a lot of organic matter to those sandy soils, perhaps, which will then also then help with water holding capacity and things like that. Other guidelines might as well be things like, don't apply tons on top of bare land on a slope, because it's going to wash away. You need to think about these practicalities, and these are things that are still being understood as we're sort of scaling up.
Thanks.
The next question was going to be about the maximum amount of biochar that you could apply or that would be in the soil without compromising the soil function. But you gave an excellent answer to that earlier in response to one of the earlier questions. Go on, Colin.
Yeah, just to add in, very much all talk so far has been around arable land, but for grassland, trials going on with Bangor University, who are one of our partners in the biochar demonstrator, is we've characterised some 13-year-old biochar, and that's been applied at a dosage something like 40 tonnes per hectare without any adverse effects being observed. So potentially for grassland, and clearly you are removed from the food chain, does give you scope for higher amendment rates, as does forestry and woodland. Right,
that's great. So what we'll do is we'll probably mix that response in with the earlier response on that Tom gave. Yeah, so we'll do that. So I won't ask the question again, but we've captured that because we're recording, so we'll try and edit that back in.
Yeah.
Note to self. Yeah.
Yeah, another note to self on the next question is about modelling. Pete, what do you think? Feel like?
Yeah, we haven't really covered modelling, so we could ask that.
It sort of segues a bit with what you were just saying, so I'll go for it. So yeah, is there modelling which can tell us when this can be achieved under different land uses or climates or environmental scenarios? Is the scope for storage less, for example, in carbon-rich soils, as in, for example, in Scotland, than in carbon-depleted soils? So I guess the question is around, how can people look at the work that's been done to, get more nuance about, when they're thinking strategically about the use of something like storage.
Yeah, if I can start off an answer to your question, the modelling we've done is very much around feedstock availability, how much of the feedstock you've got and in what area. And from that, and one example is surplus straw is based on what's available. Where would you actually situate your biochar production facilities, and what scale would they actually operate at? What you've asked is really the follow on from that. The next stage is, okay, you've got your production facility. Can you deploy the biochar in that region rather than having to transport it hundreds of miles? And I think the simple answer is your question will become more important as production capacity increases, because that will start to bring in factors more and more which will constrain agricultural use. And as I've indicated previously, you may well go down the aggregates rather than the agricultural pathway for deployment. Tom, anything you'd like to add?
Yeah, so I think as well, we're talking about the idea of having soils already starting with a high carbon content versus those that don't. Yeah, okay, so we have to be careful of our carbon to nitrogen ratio. We don't want to push our agricultural soils too far. I think it's also worth talking about peat restoration and maybe the potential role of biochar in that. Because I believe there's research taking place at the moment in whether or not you can incorporate biochar into peatland, and that can then help restore it. And then that's another carbon stock. You're already starting, hopefully, with an area with a very high carbon amount, and you're encouraging even more carbon into the soils, whether that be for agriculture or pluviculture, or if you're talking about upland peats.
But potentially a big plus with biochar is emerging data, certainly for peat. Methane reductions are reduced significantly. For soils, there are various effects noticed, but I think the perceived wisdom is some of those effects could be transient. Okay, you might see them initially, but they will rapidly die off, and the amounts of greenhouse gases involved in that are relatively small in relation to the carbon that is being sequestered.
Great. So my final question is, are there any estimates of the achievable abatement potential of biochar in the UK, in terms of megatons of CO2 equivalents per year that could be removed? And are there any estimates of the technical potential, and what's the achievable potential? Has anybody done that modelling yet?
Yeah, because I think, there's always potential. There's loads of stuff published on in the literature. In terms of potential, it could meet a very high proportion of the 2050 greenhouse gas removal target, which is estimated to be somewhere in the order of 70 to 80 million tons, based on what we've done. And there is an immediate target for 5 million tons of CO2 removal by 2030. That we think it is certainly achievable to maybe look around at the order of 5 to 10% of the 2050 target as being achievable, both in terms of feedstocks which are going to be available for production, and being able to deploy it, both in agriculture and also in aggregates.
Right, that's not to be sniffed at. That's quite a large amount of abatement potential. But we're currently doing nowhere near that. So what are the barriers? How do we upscale it? What are the barriers? How do we get there?
Yeah, I think if you just take 2030 target at the minute, it's partly regulatory framework, and is what we're doing in the UK, out of step, particularly with the rest of Europe. And I think from all our stakeholder interviews, there is not a huge appreciation of the regulatory barriers you face today with respect to biochar deployment, but we think this will change, and when this does change, then one can see the potential increasing, and of course the economic driver to all this is the price of carbon. So if the price of carbon goes up, then biochar, all of the things equal, does become more attractive. And of course, if you are come up against barriers for agricultural use, then, as I've now mentioned on several occasions, the potential for deploying biochar in aggregates for construction and roads is huge.
Is it only these? You sort of mainly talked about the legal and regulatory sort of barriers. Are there any barriers? I mean, do farmers know about biochar?
Yeah, precisely. There are barriers right across the chain. First one's feedstock availability and what are competitive uses as of today. Getting everybody to understand the regulation, and as we've indicated from our stakeholder events, and we've run special events from farmers, the farming community needs to be on board, and given the not entirely predictable nature of biochar, then clearly farmers need to be recompensed for the service they are providing.
Thank you.
Just one final question that we didn't quite cover, and it's a little bit around stakeholders. So I was wondering if biochar is mostly, or is most biochar in the UK produced in the UK, and is there a kind of stakeholder landscape out there that you're aware of that we wouldn't know anything about?
Sorry, could you repeat the question again? I didn't quite catch it.
Okay, I'll start again. So I'm going to ask about sort of who produces biochar, because some of the questions that we hear quite often are, does it come from the Amazon, for example? And I don't think we've really faced that one head on. So I'm going to ask about where the biochar that people might come across, they were looking for it in the UK, where that generally comes from, and what was who the stakeholder groups are out there. Might have specific interest. Is that okay?
Yeah, biochar is being produced in the UK.
I'll just ask it again. Ask the question again, and then we can edit it in.
Could you simplify the question a bit, Ellie? Just sort of saying, is it domestically produced or is it produced abroad? That would make it easier, right?
Yeah.
I think clearly the one thing we don't want to be doing is importing biochar, because that.
I just asked the question, and then we can put it in as a question and an answer together, if that's all right.
So hold fire, Colin, and wait for Ellie's question.
Sorry, I'll start to answer your question, Pete.
Yeah, I'll ask the question and then you can answer it. Brilliant. So in terms of where biochar might come from, is it produced, generally speaking, produced in the UK or locally, or does it come from other places, and what sort of companies are involved in creating it?
Yeah, ideally biochar should be produced locally, both in terms of where feedstocks are available and where it is going to be deployed. If not, then you have to really consider life cycle emissions associated with transportation, which are generally greater for feedstocks because they're generally less dense than the biochar you are actually producing. So I think the general consensus is, we don't want to be importing biochar. One, because of the cost of associated life cycle emissions. Biochar production facilities do exist in the UK. We're not producing huge quantities of biochar. Probably, if you sum them all together, I would say it's probably no more than the order of 2,000 or 3,000 tons of biochar. Currently, we need to be careful. There are a number of charcoal producers in the UK, and whilst charcoal is clearly their major product for combustion, they do produce finer material which sometimes gets branded as biochar, where in reality biochar should ideally be the major product of your production process rather than just being a byproduct stream.
Thanks. Well, I think that's all our questions today, which has been really fascinating to hear the wealth of information and work going on in this area. Thank you so much, Colin. Thank you, Tom. And do look out for talking heads in our series.
Yeah, okay, very good. So before we finish, have we covered pretty much everything you wanted to be covered?
We did, yeah. There was this one question at the end. I don't know what you think, Pete, about
prions.
Yeah. Is that useful?
Yeah, that would presumably be when you're using an animal feed. Is that what they're thinking of?
I think so, yeah. That came from Scotland, that question.
Yeah, I think it's right. Animal feed is a very niche market as opposed to, the mass market we're thinking about in terms of biochar contributing to GGR.
Yeah.
Should we ask the question?
Do you want to ask it, Pete? Because you can probably simplify it better than I can.
Let me look. Tom, you're shaking your head. Do you think it's...
Oh, no. It's very, very niche. I know very little about it. I mean, I couldn't fully follow what they were talking. I mean, the actual pyrolysis process I would have thought would destroy all prions, but I can't see how biochar itself could damage prions. I couldn't quite understand it. That was all.
I think the questions work, so I think we should leave it.
Okay, I think you just got beeped out.
Yeah, it's all right. No, I mean, we're not going to put that in the final edit, are we?
I don't think so. Yeah. Wait,
I think we leave it.
Yeah.
I mean, yeah, like pyrolysis I would have thought would destroy prions, but I can't see how biochar itself could have that effect when they're incredibly difficult to destroy. I mean, you could talk about reactive oxygen stress and things like that, but which is more sort of microbial stuff, but that's not going to happen on the surface of biochar with a prion. I don't think so. It's very, very niche.
Yeah. Wait, I'm going to stop the recording.
Better word than bollock. Thanks, Tom.
Brilliant. Well, thank you so much. So we will, you'll hear from us, I'm afraid, with a little job, because what we'll do is we'll take the transcript and we'll turn it into something that is sort of, very plain English and send it back to you therefore to check that we haven't oversimplified anything or misunderstood anything in the written document. And then we'll just edit this to a neater version of what it is, and it will go up on the LUNZ website, and then hopefully you can share it with your people community as well.
Okay, very good.
Thanks very much, Colin, and thanks very much, Tom.
Thank you. Yeah, bye. Have a good weekend. Bye.
Yeah, and you.
Bye.
Bye.
Each should grab a cup of tea before the next one. Yeah, see you in 5.
Are we meeting now, Ellie?
I think so. I'm just going to look at the calendar.
Okay.
Do you want to have a break? Because
I just need a wee, and then I'll come back.
Yeah, I need a cup of tea, so I'll see you in a bit. I'll close this one. We'll open the other one.
Yeah, brilliant.
See you later.